In this presentations, we are going to discuss about syntax director translations and intermediate code generator with the subtopic as type and declarations and translations of the expressions. Type and declarations. Type checkings uses a logical rules to reason about the behavior of a program at runtime. Specifically, it ensures that the types of the operands match the type expected by an operator. Translations applications. From the type of a name, a compiler can determine the storage that will be needed for that name at runtime. So this type expressions can be defined as by the structures. So here the types have a structure represented using the type expressions. A type expressions is either a basic type or is formed by applying an operator called by the type constructors to the type expressions. The set of basic types and constructors depends on the language to be checked. So consider the array. It has a type integer with 2 cross 3. Here the number of elements is 6 elements. So the array of 2 arrays of 3 integers each and returns as a type of the expressions array of 2 comma array of 3 comma integer. So this type of representations is done by the tree. So the operator array takes 2 parameters, the number and type. So the tree describes the type expressions. Here the root node is an array, the left side is 2, then the right is array because it is in 2-dimensional array. Okay, so here the left side is 3, that is the data types of the element is an integer, so that is described in this right side. So the type name is a type expression. The type expressions can be formed by applying the array type constructors to a number of elements and a type expression. A record of a data structures with the name field is defined in the types and declarations. The type expressions can be formed by applying the record type constructors to the field names and their types. The type expressions can be formed by using the type constructor. For the functions types, we write the S implies T for the functions from types S to type T. So the functions types will useful when the type checking. Then type equivalence. So when we used 2 type of expressions equivalence, so many type checking rules have been formed. If 2 type expressions are equal, then return a certain type else error. Potential ambiguity arises when names are given to type expressions and the names are then used in subsequent type expressions. The key issues is whether the name in type expression stands for itself or whether it is an observation for another type expression. So in this declaration statement, actually the D, capital D is a starting symbol of the grammar. One declaration statement has data type and the variable. So here the T is defined as a data type. Then ID is a variable. Sequence of declarations. So the sequence language is such that C and Java allow all the declarations in a single procedure to be processed as a groups. The variable offsets is used to keep track of the next available relative address. Actually, the C languages are supported the multiple declarations in the single procedures. So in that time the offset calculations is an essential for the allocations of the memory address for each identifiers. So the declaration part has data type and identifier. In that time the particular identifier is entered into the symbol table with the corresponding lexeme values and the type of the data type and its offset value. So the offset is incremented by the width of that variable size. So example, if for the one single variable. If allocated the memory space thousands, means for the next integer variable it allocate 1004 isn't starting address for that variable, because each integer allocate 4 bytes in this Pascal language. So the offset values is incremented based on the length of the data type, so that the offset value is incremented by t dot width. So the translations of the expressions and expressions with more than one operator like a plus b star c will translate into instructions with the most one operator per the instruction. So operations with the expressions can be built by 3 address codes for the assignment statements, as using the attributes codes for this and attributes add and code for the expressions. Actually the 3 address code is generated by using the attribute of code and the address. So this is the translation schemes for 3 address code generation. So for expressions, consider expressions has a sub expressions e1 plus e2. So you have to create a new temporary variable for the left side non-terminal e with the attribute address. So that is e.addr is a new temporary variable. Then what is in code for that? E dot code is has the concatenations of the code e1 and e2 with the operator plus. That's enzymatic actions for 3 address code generations. Thank you.